I appreciate the opportunity to present this morning. I'm going to try to cover a lot of information, what's going on here at SPC, and we'll hopefully have some time for some questions. I'll try to stop after each little section. So we're going to cover hazard intensity information in mesoscale discussions, and I'm going to share some outlook, and if we have time, some quantitative decision support stuff that we've been working on in the background. All right, so hopefully you've already seen this with the hazard intensity ranges in the real-time mesoscale discussion graphics. This goes back to the hazardous weather test bed spring forecast experiment in 2023, where the concept was developed and tested. The results were promising, and SPC began an internal operational test in roughly a year ago. And with that, we decided that, hey, we want to come up with ways to provide intensity information, but we're still doing it as a forecast, not just purely some sort of diagnosis. So we settled on a series of overlapping intensity bins, and we're looking at roughly the 4 hours after the MD is issued to verify these forecasts. And then we're looking for the most probable peak intensity range for all three hazards. And in this case, I'll show a lot of the information for tornadoes just because we've looked at that, but the same thing applies to hail and wind as well. We've also verified these background forecasts that we've been doing. To this point, we've had a chance to verify just under 1,900 of them from last April through November. So that was a good chunk of the peak severe season in 2024 and some of the cool season, the early part of it this past fall. Our goal has been for these intensity forecast bins, for the actual outcome to fall within the forecast range, roughly 60% or more of the time, and within plus or minus one of these overlapping bins, approximately 90% of the time. So that's what we were hoping when we started it, and I'll show you a little bit of verification that suggests we're not that far off in the first year into this. And again, if you wonder why is SPC bothering to do this, it's just part of a larger effort to increase intensity information in not only the mesoscale discussions, but in our convective outlooks, which I'll talk about here after the MDs, and some decision support in the so-called watch the warning gap. And we have an internal conditional intensity outlook that informs a first guess for these MD intensities. And we wanted to also provide some quantitative information, much like the warnings do with, the hail size and wind speed, so that we don't rely on this ambiguous language that, what does somebody mean by this word? Because, we see that all the time with our categorical labels. People get all upset about this one isn't as bad as the one that's below it or whatever. So anyway, what we came up with here is a scheme. Don't bother trying to memorize all this. That's not the point. This is something that'll just be sitting in the background. I'm just illustrating how they overlap. So if you focus on for tornadoes, peak wind speed of 100 to 130, that's, EF1 to EF2 range in general. Notice that the next bin up overlaps by 10 miles per hour. So these are slightly overlapping bins, and as the wind speeds get higher, peak wind speeds, obviously the potential impacts get worse. And we just do the same thing for wind and the same thing for hail. All right, so the process, or the way we've been doing this, is this little inset on the upper part of the screen is an actual outlook from just not too long ago. It's a couple of months back, and with an enhanced risk 10 hatched area centered in the Louisiana, Mississippi, Arkansas area. And in that case, we also are doing an experimental outlook in the background, which is the somewhat larger inset. And you notice the hatching covers a different area. It's more expansive and it's not limited to just the 10%. So I'll talk about that more, but given where the MD area was, which is highlighted in red on top of the outlook, a 10 conditional intensity outlook 1, I'll talk about what that means, that grouping, historically, that a first guess for when tornadoes occur would be peak wind speeds in the 120 to 150 mile an hour range. So somewhere from lower middle EF2 to middle EF3. So a strong tornado would be the first guess. And then you see the little table that comes out of this. The forecaster actually can modify this. And in this particular case, the forecaster there was a peak damage indicator, wind speed of 132 miles an hour. So, and it was in about 90 minutes after the MD there in north central Louisiana. So pretty typical of the way these things turn out. Here's some verification. Again, a ton of numbers. I don't expect you to memorize all of it. The main thing is these left bins. So if you take the second column, the same bin is the tornado. When a tornado, we put out a forecast, the actual outcome is falling in the bin that we forecast 73% of the time. So that's actually better than our goal of 60%, but this does include null cases. So we were correct with a lot of nulls. So out of 1,862 MDs, there were only tornadoes in them 455 times. So the null cases are giving us a lot of, a little boost in the statistics. But if you notice here for the TOR forecast, the wind forecast, the hail forecast, those are all near 90% within plus or minus a bin. And the verifying in the same bin ranges from 55 to 73%. So we're almost right where we want to be. And if you look over here in these positive adjust and negative adjust columns, basically, does the forecaster make it better? That's a positive adjustment. If you compare the percentages, it's either 2 or 3 to 1. We're improving it versus making it worse from the first guess. So the forecaster's adding some nuance here in these 1,862 MDs. Now, if you only look at events where the hazard occurred, we don't verify quite as well. Early in this experiment, we had a tendency, we undercut too many of the tornado ones. We were going too weak. And you notice here with the positive and negative adjustments are almost an equal percent. Whereas if you look at wind and hail, it's still about 2 to 1 where the forecaster's improving things. So we're still close other than the tornado one. We're 55, 58% in the same bin. Our goal is 60. And then we have for wind, it's 90% and 87%. So we're already almost where we want to be. And this is just in the first year of our experiment. Okay, I've shown some 2025 recent examples since we went live with this. And this is all just from this past weekend, pretty much. Here's a low wind example of what it would look like. And this was a wind threat into Western New York this is the day after the 2 big tornado days. And this just shows you what the colors are meant to highlight. It's on the low end of the scale, kind of what I'd call run-of-the-mill peak thunderstorm winds, near the lower end of severe. And then tornado in this case, it's just a weak tornado type environment. And I don't think there were any verified tornadoes in this MD area during that 4-hour window. Now here's one that I did a couple of nights back in the Southeast Atlantic coastal plain, where the arrow from the box goes, the strongest tornado was in EF0 with peak winds estimated at 80, and it was a 4 1/3 mile path. So in this case, I was a little hotter than that with the tornado estimate. I was in the 85 to 115 range. So it verified a little bit below, but not too bad. And that was a good 45 minutes to hour before it happened. And then just pretty typical wind forecast. So the examples I'm showing will keep getting to higher intensities. This was later the same day. We're Pittsburgh, where we had upgraded to an enhanced for wind. So the wind is no longer in the bottom of the scale. We're now getting toward the middle with the potential for significant severe and that same tornado bin. And in this case, the tornado, it was just after the 4-hour window. So this was pre-watch. And it verified with a 7.7 mile path with peak winds estimated at 100 miles per hour, which is right in the middle of the range. And so it was this was a little bit beyond our forecast window, but not too bad. Now, how do we do on the higher end tornadoes? This is a case from back in mid-February where in the composite reflectivity image, this is actually a developing supercell east of Hattiesburg, Mississippi. And by the time that storm got to the Mississippi-Alabama border, it produced a 26-mile EF3 with peak winds rated at 150. That's right at the top of the range that the forecaster suggested. And I think this was an enhanced risk day, if I remember right, with a 10 hatch tornado area. So again, the forecaster has some ability based on storm mode to bump these numbers up or down. And in this case, they stuck with that first guess and it actually verified pretty well. Okay, we've just had some high-end tornadoes. Here's the southern Mississippi from the Saturday early afternoon, and this was a pretty hard-hitting MD that Evan Bentley put out. And you'll notice here he's got peak tornado wind speeds of 155 to 190. That's upper EF3 to upper EF4. So this is almost as bad as it gets. And in this case, there was a 65-mile path EF4 with peak winds estimated at 170. And that was about 45 minutes after the MD was issued. So in this case, you know, and I'm not just trying to cherry pick them. Obviously, we have cases where we over forecasted or we missed things, but in general, these were just very recent events. So we have some rollout. Obviously, we've rolled out the graphics here in mid-January with the information, and based on WFO requests, we made some changes to the color scheme. On the low end, it's yellows instead of greens. And here coming up soon, we will actually include the same information at the end of the mesoscale discussions as parsable text. It'll look a little bit like the warnings do with the hail and the wind speeds. And if you may have seen the service change notice that was sent last week. So any comments or questions on the MD intensity stuff before I move to the convective outlooks? All right, if I don't hear any, we'll just move right along. I got plenty of material here. So we have been working on this for a little while, and it's something that we hope to share at least on the internal webpage here sometime later this year. With all the distractions that you are all more than aware of, it's been hard to keep focused on some of these things. But here's an example of an outlook from late last year in the of a moderate risk with a 15% in the red area and a hatch to go with it. Here's what this conditional intensity outlook done by the same forecaster at the same time looked like. And you notice the hatching isn't confined to the 10% area anymore, and we've also got a double hatched. What we're really doing is we're trying to see if we can forecast tornado intensity distributions and not be so strongly tied to the tornado coverage probabilities. So historically, when we issue this 10% or greater hatched area for tornadoes, EF2 plus tornadoes, hurricane force gusts, and 2-inch or greater hail, it actually verifies somewhat as a function of storm environment and the probabilities themselves. So I'm just going to focus on tornadoes here. When we do a 10 hatched, which we have one today up in the Midwest, the verification is closer to 5% grid coverage. So, but what happens when we issue a high risk, which is a 30% hatched is the minimum, the percentage of EF2 plus is actually 4 times higher in those. So it's not just that, and we're also getting more intense tornadoes. So we're shifting into a different distribution of tornadoes, and we want to be able to reflect that in the forecast. So we've devised a new scheme that's less constrained by the unconditional tornado probabilities, and we want to try to link it to storm environment and storm mode, and then we can use the environment as a first guess for these conditional intensity groups. It happens, we pronounce it the same way as we do the SIG area. We're just saying with the starting with a C, so a conditional intensity group. So SIG 0, we're defining it as where basically you're less than climatology. If you just randomly pluck a tornado out of the pile for that distribution, less than 10% of them are EF2 plus, whereas broad climatology for the whole CONUS is more like 15%. Now, conditional intensity group 1, we've actually gone above climatology by a little bit, and I'll show you how we relate this to storm environment in a minute. Then there's conditional intensity 2, or this is what we call the double hatch. So SIG 1 would be single hatch, SIG 2 is a double hatched. Now we've doubled climatology in the rate of SIG torque reduction. And then there's even a SIG 3 for some historic type events where you're starting to approach almost half of all the tornadoes are significant in that type of the parameter space. So We can do the same thing with wind and hail. I'm not really going to show that today for the sake of time, but and we only do up to a double hatch for those two because the environment's not nearly as good a discriminator as it is with tornadoes. Okay, so speaking of tornadoes, if you look at the peak outbreak part of the season, which is November to May, and we're still in that time of year now. If we break the distribution of tornadoes down, so this graph just shows for values of, and this is just one way to do it, not the only way. This is using the significant tornado parameter for all of the tornadoes that occur when SDP is less than 1, and this is based on our mesoanalysis archive. Only 7% of all the tornadoes in those environments historically were EF2 or greater, and very few EF3. I mean, it's 1% and essentially nothing for violent tornadoes. If you go to somewhere between 1 and just under 4, the percentage of SIGTORs actually triples just going into the higher SDP parameter space. And if you keep moving, you notice that the yellows, oranges, and reds, the higher end tornadoes, get more and more frequent. I mean, they're still not dominating the distribution, but over here in SDP less than 1, 60, it's likely that you're going to be EF0 is the, whereas if you go over here to SDP of 7 or higher, which is a really high end environment, the probability of an EF0 is about half of that, but the probability of EF3 is 14 times higher than it was for that low end environment. So this is one way we described it. We use the storm environment as described by STP to give us this no hatching, single hatch, double hatched, and triple hatched. Now we do consider storm mode in there also. This conditional intensity group 0 and 1 are the same as you had on the other plot, but here we just show what does it look like when the storm mode is just QLCS or it's tornadoes just with tropical cyclones. You can see that the TC tours actually kind of look like the no hatched environment. The QLCS tornadoes, and especially if you focus on them in the cool season, is a little higher, but it's not quite background climatology. Whereas I'm not showing it today, but the supercells clearly are what are driving this conditional intensity group 1. So you could argue there's even some nuance in here where there's like a sig 0.5, like a half of a hatch type thing is representative depending on the type of storm mode. All right, so I'm going to show some examples of these, and they'll just have the same. There's only 3 of them. It'll be the operational outlook on the left, and on the right we'll have the archived conditional intensity forecast that was produced in real time for these events. So here's the one from Friday where we had a moderate risk. It was a 15 hatched tornado, and you can see there were a lot of tornadoes, especially Arkansas and Missouri. The conditional intensity outlook, you notice that the hatching goes farther downstream, and this is to allow for the possibility, hey, if a supercell gets going, even though the probability of a tornado is lower as you go to the east or northeast, if a supercell or something survives, there's still some potential for a higher impact event. And then we also have this broad area with a double hatching, which is one easy way to think of that is, the single hatch in this scheme is EF2 plus, the double hatch is EF3 plus, triple hatch is actually like violent tornado potential. So now, what does it look like with wind? Here's one from 2 days after that. So this was, I guess it was Sunday, and we upgraded to a 30 wind over here on the left, centered on Pittsburgh's area, but we did not have any hatching in the operational outlook, but we did add it in the conditional intensity space, and there actually were, I think, 3 hurricane force wind estimated gusts in there based on the damage. I don't think they were measured, but point is there's more nuance, and notice the probabilities are exactly the same in both outlooks, but we've got this additional, the forecaster had confidence to do this single hatching in the new scheme because it's not so tied to the coverage as the old one. So we're just not sure if we're going to get 10% or greater coverage. We don't do it operationally, but we can say, hey, worst case scenario, there could be a few SIG wind events out of a lot of wind events overall. And then hail, Here's just one from last year. We actually have a first guess based on the environment, and that's on the left. It shows the single hatching across West Texas, Southwest Oklahoma. And notice the hatching goes well into the 5% areas. That's the only restraint, is we don't draw it outside the probabilities. But in this case, the forecaster did not have that first guess available. We do now, but they did. You notice they drew the hatching all the way out to the 5%, which represents pretty typical in the plains, all the way to the dry line. You're not sure where the storms will form, but if they form, there could be sig hail. In this case, the forecaster added a double hatched area, and there were multiple baseball to softball reports through here. So in this case, the double hatched is just a reasonable worst case scenario of like 3-inch or 3.5-inch or larger hail, and it looked like it verified pretty well. Okay, so our main reason to do this is we want to provide more nuanced information to help with decision support, and we hope to share this internally sometime later this year. I thought we were going to be doing it by now, but you know, the world changed 2 months ago, and we'll see if we can get that out there, but we're still making progress in the background. Meanwhile, with this new conditional intensity framework, we are working on a recalibration of our probability to categorical scheme. And in this case, this is just where we stand now. We're not necessarily locked into this, but the point would be is if you look at the wind and hail for the SIG group 0 would be no hatching. You notice nowadays, like take the wind, 5% is marginal, 15 would be slight, but if we went to 30, that isn't enhanced in the current scheme, but a 30 with no hatching in the new scheme, we think that's actually more appropriate to be a slight. And then the coverage, if we don't expect intense events, the coverage can keep going up, and we'll even allow potentially for a 75% coverage probability, which is even higher than what we draw now, would still just be enhanced. So we want to, if you think back to the way the outlooks were prior to 2014 and the introduction of the marginal and the enhanced area, the slight used to have 4 possibilities for wind and hail. There was a 15 hatched, a 30, or a 30 hatched. Now we want to go back to something like that where there's a little more nuance, and say for widespread wind events, but not particularly intense, for someone may be very busy with warnings, we want to be able to reflect that in the outlook without every single change in a contour driving a categorical change. So that's kind of what we're getting at there. So any questions on any of that before I show you some societal impact stuff? All right, we'll keep moving along here. This one, we want to take part of the vision here was Russ Schneider, the director of SPC, had the idea that we could potentially use this conditional intensity framework to maybe try to estimate directly what societal impacts might be. And so what I was tasked with doing was I redid some historical events, and I'll show a few examples here before we wrap this up, and to see if we can actually estimate what might happen based on the forecast that we're issuing. And a lot of the background work has been done by Patrick March and Joey Pica, who also work at SPC, but they've developed a machine learning model and a Monte Carlo approach where we run roughly 10,000 simulations of different possible tornado outcomes based on our outlook. And then we can estimate things like numbers of tornadoes by intensity, and we can even come up with estimates of fatalities and injuries. Okay, so here's the actual tornado tracks from March 31st of 23, the dual high risk. And you can see that, this was a pretty good forecast. And when we try to simulate a forecast like this, here is just one of the simulations. This is number 8,974 out of the 10,000. And you can see that it doesn't look exactly like the outcome. And the tornado tracks in the simulation are a little bit focused toward the higher probability areas, but not all of them. Some of them go into the lower probability areas. And so what you can do is if you come up with an estimate of here's one possible outcome, you can take every one of these tornado tracks, and you also have the underlying population density, the structural stuff, and you can actually estimate the impacts, the damage, and the potential societal impacts of each of the tornadoes, and then we can come up with statistical distributions. So here's the conditional intensity outlook for that event, or a reasonably good version of that outlook. And again, this varies from the operational outlook because the hatching can go all the way even into the 2%. That's a suggestion that, hey, the probability of a tornado goes down as you go to the east, but if a storm survives, it's still a very strong wind profile, and there's still the possibility for a significant impact event. It's just the overall probabilities are lower, but if you get a tornado, it could still be significant. Okay, so here's what we're able to produce using these outlooks. So I'm going to start with this middle exceedance matrix. Bottom left, this is the probability of, or all intensities of tornadoes, and then on the bottom, it's just numbers of them. So based on this forecast and historical verification, there's virtually all of these lower end outcomes. There's 100% chance that you're going to get one or more tornadoes of any intensity, even all the way up to 20 or more tornadoes, because this is a dual high risk. It's a very rare forecast. If you go all the way to the upper right, this is the probability of 20 or more EF3 plus tornadoes. That's a terrible day. I mean, huge number of intense tornadoes. And that's about a 1 in 7 chance, which is way, way, way above normal. So taking that forecast, all the simulations, we can do distributions of the tornadoes here in the upper right. And if you look at the EF3 plus, this is like a horizontal box and whisker type plot, and the interquartile range and the median are in black, and generally the 90th or 95th and 5th percentile, I think, is what we have here. But the median number of EF3 plus based on the outlook is 12, and it verified with 11. And you can see that the verifying numbers are the ones on the bottom in gray, and the forecast are in black in the smaller font. All of the verifying numbers are well within the distribution. So this says we have a pretty accurate forecast, and the way it played out didn't vary greatly from what we were forecasting. If you go to the bottom, based the statistical distribution, the median number of fatalities based on those 10,000 simulations was 42 people. The observed was 25. And the injuries, 377 is the median, observed 225. Those are on the lower part, more like the 25th percentile, but they're clearly in the distribution. And you could argue this day played out as, it wasn't that there weren't tornadoes, it's just that the big tornadoes, other than one in Little Rock, there was like a long track EF4 in Iowa that missed Ottumwa by a few miles. If it had hit the towns in Iowa, this would skew the distribution clearly to the right. And then if you're interested, there's also recurrence intervals for this type of forecast, and you can see that the median is, this is a once every 5 to 10 year type forecast for the whole CONUS. Okay, so let's go with some of the big ones. This was very close to the probability forecast that I put out the morning of April 27th. I've just added the conditional intensity distributions to it, and in this case, there's a 45 triple hatched in parts of Mississippi, Alabama. That's about as high as we would ever go. Here's what the forecast looks like. So if you jump all the way up to the upper right portion of this exceedance matrix, the probability of 20 or more EF3s is better than even chance based on that size area with those intensity of tornadoes. And in this case, it's you look at the numbers, the actual verifying tornadoes are slightly more like the 75th percentile of that distribution. And the same thing if you go down to the fatalities, 316 fatalities is way out at the edge, but there were a few simulations in there that came up with that. So you could argue that this forecast was actually pretty close, and it maybe just verified as more of a worst case scenario. There was actually more stuff hit than the typical outcome that you would expect in this case. And that's why, I mean, 300 fatalities, that's one of just 2 or 3 days ever that have had that many fatalities. So we can continue on. Here's an Eastern US case that was just, 10, 11 days before that. one I just showed, and this is a 30 double hatched. It was a high risk and centered in North Carolina. Again, if you look at this one, pretty accurate. The tornado counts, they verified, more like the 75th percentile with which is the right side of the black box on each of these and those numbers. And the same thing happened with the fatalities and the injuries. And the injuries are a little less trustworthy because the data that drives those estimates is a little bit less believable, whereas there's a lot more attention paid to the specific fatality count. So in this case, it looks like it was a reasonable outcome, well within the envelope of the forecast possibilities. And last but not least, here's the one from Friday that we ran. And it's a different format on this graphic, but you'll notice here, tornado counts, they verified near or just above the 75th percentile, and the fatalities and injuries were right near the median. So the red dots are what has actually occurred, and that's what we have so far based on the public information statement. So that's I think that's all I got here. So any questions or comments on any of that?
Thank you, Rich. People who have questions, feel free to raise your hand or enter them in the chat.
All right, well, if I don't hear any, that's fine. I just, in case anyone wonders, the intention with that last part, the forecast of fatalities and things, we have no intention of making that public, but the idea might be to share that with the WFOs and maybe the region, state level, and then national FEMA, that sort of stuff. That would be the intended audience. We would never suggest putting that out on like TV with the evening news and said, oh yeah, there's going to be 50 people killed this evening and that sort of stuff. And yeah, I see Jenny's comment there. So yeah, we're going to try to start sharing that on a more regular basis. So we're almost shocked at how well it seems to work. Now, as long as you just don't have a bad outlook. Bad outlooks, there's no way to fix them, but give you bad estimates. But so far, so good. And like Saturday was a slight over forecast by this technique. We were running a little hot for the Mississippi, Alabama, but it wasn't way off. It was just we were a little bit on the lower end. So again, appreciate the opportunity this morning, and anyone has any questions, y'all just hunt me down with the email.